Hi, it's Mr. Anderson, and this is a beginner's guide to graphing data. I continue to be surprised by the simple mistakes that are made by students in my high school science class when they try to display their data in a graph. And I think the reason why is that we spend a lot of time in elementary school on graphing, but as students move from middle school to high school and on to college, we don't spend very much time on graphing. It's just like reading. We assume that they know how to do it. And so I put this video together to show you the importance of graphs, the different types of graphs, and even give you some practice graphing some data. And so first of all, let's start with the term graph. The term graph and the term chart can be used interchangeably. They mean essentially the same thing. And so you'll hear me go back and forth between chart, graph, plot. They're basically ways that we can take data and display it visually. And so why do we use them? Well, let me give you an example. This right here is Charles David Keeling. He spent years and years and years on top of Mauna Loa in Hawaii collecting data on the levels of carbon dioxide in the atmosphere. And let me show you less than 1% of the data that he collected. It's almost incomprehensible to us. When we get a huge list of numbers, we can't make sense of it and we can't find patterns. But if I were to show you all the data that Mr. Keeling collected, we would find the Keeling curve. And this is one of the most famous graphs in all of science. It's basically showing increasing levels of carbon dioxide. You see annual cycling of carbon dioxide. And this is very important because it's tied to global warming. And so when we can see the data, we can make sense of the data. And so there are 5 major types of graphs that I'm going to talk about in this video. They are line, scatter, bar, histogram, and pie graph. And so I want to start with a little pre-quiz and see what you know. And so could you right now point to the line graph on the right? Let me show you if you're right. Line graph is going to be that one. Could you point to the scatter plot now? And what about a bar graph? Could you point to the bar graph? And the histogram? And hopefully you can point to then the pie graph. Okay. So how did you do? Did you get all those right? Hopefully. The ones that are confusing, obviously a line graph is going to be dots connected with a line. Even though we have a best fit line here, the scatter plot is not going to connect the dots at all. It's going to show correlation between number sets. Did you get screwed up on the bar graph? How do we tell the difference between a bar graph and a histogram? Bar graph, we're going to have space between the different columns. In a histogram, they're going to touch. And so the reason it's important that you know and can identify the different graph types is that as a scientist, you're going to collect data, and then you're going to have to choose what graph you're going to use. In other words, the data always comes first, and then you've got to figure out what graph you're going to use. And so let's talk about 5 different types of graphs. First one is going to be a line graph. We're going to use a line graph if we're looking at change over time. And so in this one, we're looking at U.S. trade in goods and services. And so you can see that the dates are going to be along the x-axis, and then the monies are going to be along the y-axis. And so in science, maybe we're collecting data on an individual worm and how much oxygen it respires over time, or it consumes over time. Then a line graph would be a great example. Let's say we're looking at a scatter plot. We're going to use that when we're correlating 2 number sets or 2 sets of data. So it's a correlation of variables. And so this scatter plot right here, they're looking at the eruption of Old Faithful, how long that eruption takes, and then the time between the eruptions. And you can see that there's a relationship between those two. Scatter plots are really important in a science classroom. Forever varying one variable, we call that the independent variable, and then measuring how that affects another variable, we call that the dependent variable, then a scatter plot is going to be the graph of choice. And so when you're doing that, make sure that you put the independent variable on the x-axis. And so let's say that this plant right here, I'm doing an experiment where I vary the amount of fertilizer, and then I measure how much that plant grows over time. Well, since I'm varying the independent variable, I'm going to put that on the x, the amount of fertilizer, and then we put plant growth on the y. And we look at a correlation between those two. So scatter plots are incredibly important in a science room. What about a bar graph? We use a bar graph if we're comparing 2 groups together, or more than 2 groups. And so in this bar graph, we're looking at worldwide incarceration rates, and we're comparing different countries. Let's say in the lab we were measuring how different colors of light affect the rate of photosynthesis. Then we could put the rate of photosynthesis on the y-axis, and then we'd represent each of those different colors of light using a different bar. Lots of times a bar graph, that bar is going to represent the average or the mean of all the data that we collected. What about a histogram then? Histogram is when we're looking at the distribution of data. So let's look at this histogram here. We're looking at the height of black cherry trees. We have different heights along the bottom, and then we just have the number of trees on the side. And so, for example, how many of these cherry trees are going to be between the height of 70 and 75 feet? Well, we'd look here, and then we'd find that that's going to be 8. So let's say we're graphing humans' height along the bottom, and then we're looking at the frequency. That would be a histogram. And then you're probably familiar with a pie chart. We use that if we're ever looking at parts of the whole. And so these are all the different families of rodents, and then we can see what percent each of those are of each of the different families. So Muridae is going to be most popular. Those are going to be the rats and the mice. Okay, so once we've got that, which graph we're going to use, then we can actually get to the graphing. And so let's play with that for a second. Let's say I've got data from a pretend ice cream store that I have here in Bozeman. And on this data right here, I've got the average high temperature in Bozeman, and then I've got the number of ice cream cones that I was able to sell during these different months. And so let's say I wanted to display, for example, all the different months and then the percentage of the whole of which I sold ice cream. So I'd be looking at a pie chart. So I'd have all the different months as a different section of that whole pie. Let's say I want to just over time look at the average temperatures, the average high temperatures in Bozeman. What would I use? That'd be a line graph. And let's say I want to look at 3 specific months, 3 groups, and compare the ice cream sales in all months that start with the letter J. Well, then a bar graph would be great. And so let's get to a real graph and show you all the elements of a graph. So let's say I want to look at the correlation of ice cream sales and average high temperatures at my ice cream sale or my ice cream store. Then I would use a scatter plot. So let me show you all the important parts of a scatter plot. First thing you want to do is you want to figure out where your axes are going to be. And so I'm going to put along the x-axis, I'm going to put the temperature, and then I'm going to put my ice cream sales on the y. Next thing I want to do is I want to have a title for each of those. And so I'm going to put average high temperature along the bottom. Notice that I put in parentheses the units that I'm measuring it in. And then I'm going to put ice cream sales on the y-axis, and I'm going to put the units that I measure that on as well. What's next on a graph? The next is going to be the title. The title should tell you everything contained on the graph. In other words, I'm going to look at the correlation of ice cream sales and average high temperature. I'm going to tell you where it is, and I'm going to give you the date for that. Lots of times the titles are too simplistic. You'll have a title that's just simply ice cream. You have to have way more information in the title. In fact, I should be able to look at the title, and it should be the story of everything contained within that graph. What's next? Well, on a scatter plot, we're going to have the data. And then finally, we should have a best fit line. A best fit line is going to be like an average of the data. If you're putting this in freehand, basically half of the dots on your scatter plot should be above it, and then half of them should be below. A good best fit line should never extend past your data. I shouldn't put like an arrow on the end of it, because really, I can only put a best fit line within my data. I can only interpolate within that graph. So these are all the elements of a graph. Good title, label the axes, make sure you have linear numbers. So you can see here that there's 15, 15, 15 between each of those major grid lines. And we're going to have the same thing here on the Y. You've got your data points, and then you have a best fit line. And so those are all the elements of a good graph. Another important thing that students tend to do is they want to include the number 0 here. You don't have to have a number 0. If your data doesn't have the 0 in it, then it shouldn't be on your graph. So let's look at a bad graph. Let's say I'm collecting data where I'm looking at the amount of fertilizer and how that affects plant growth. And let's say that a student gives you this graph. Can you find all the errors in the graph? I can find at least 10 probably. Number 1, let's start with the title. So it's got a title, but the title isn't very descriptive. The title should show me what's going to be on my X and what's going to be on my Y axis. So like the relationship or the relation of fertilizer to plant height. Next thing, I've got plant height here, but since I'm varying the amount of fertilizer, my independent variable should be down here. So we would want the fertilizer to be down here, and then we want plant height to be on the side. We also want to make sure that we put units in parentheses that we measure it in. So we would have plant height over here, then fertilizer down here. This is a scatter plot, so you should never connect the dots in a scatter plot. Other things that we have is we have nonlinear scaling. So down here, you see it goes 5, 7, 11, 15, 17, 19. The distance between each of these should be equal. And then this number here, 12.5, doesn't tell me anything. I couldn't measure anything else on here because I'm just given one number. So you have to have at least two numbers on your grid line. You can also see that the best fit line is extending past the data. And so this is a bad scatter plot. So we're having quite a few errors on that. So you want to try to remedy that when you're making a scatter plot of your own. And so let's get to that. So basically I've got two videos that I've made. One is on graphing data by hand. And if you want to watch that, you could click on that box right here. And the other one is going to show you how to use a scatter plot, graphing that by spreadsheet. So the next steps, if you want to do some graphing, is click on one of those. And if you just wanted to learn about the good elements of graphs, then I hope that was helpful.